this thing get moved. There we
I
go.
wanted a little clarification on part B of number 4.
Okay, let's zoom into that one first. Okay, this question doesn't actually ask us to do the whole thing, as you're pretty obvious, but it does ask us to split it in the way that it would need to be split as a partial fraction. So it looks like I got that. This is my version. It might or might not be your version. The only thing I can see that is of any use is that the bottom factors out. And that means I would split it as an a over x. And then I'm not going to worry about what that becomes because they don't ask me to do anything about it. But because this is a quadratic, we get that. So we more likely in the questions that we actually do the whole thing with, we're more likely to just get an x squared plus 1 or a 4 on the bottom. But technically speaking, any quadratic would work. That makes sense? Okay.
Yeah, I was just trying to make it harder than it was. I was thinking it might need to be a b squared because I had the 3 terms. I don't know. It was just not clicking.
Clicks now. That's good. Okay. Does anybody, I haven't a note because I'm very forgetful. Did anybody get a recollection of the last number that we did? Because I've done 2 classes and I forget which one I've done which questions with. My gut feeling is that it's not right. We did 6. My gut feeling is that we did 6. 6 has y plus 2, y minus 3, things like that in the bottom. Did we? Would that be the last one that we did? Otherwise, I may end up doing the same question twice.
I don't think we did anything with y's.
Okay, so that'll be my first question then. It's a good place to start. So this is a version of question 6. And it's going to be the integral from 1 to 2 of 4y squared, take away 6y, take away 12. And on the bottom, we have 3 factors instead of the typical 2. No, you can handle that. So I'm going to take this guy and I'm going to split him into partial fractions. Would it seem reasonable that this is going to split into 3 and that each one of them is going to be a linear term? And by that I mean it's just got a single letter in the top. We're comfortable with the split. Agreed? That guy, that guy, that guy. Now, it's a little bit messier, but it's the same process. Once we've got the 3 partial fractions, don't we want to now put them all back together again? Now, it's a little bit easier when there's only 2 terms. If there was only 2 terms, wouldn't this get multiplied by y plus 2 top and bottom? And wouldn't this one get multiplied by y top and bottom? But now there's 3 terms. We have to, that has to get factored in. This term, yes.
Sorry, I'm not able to see the right side of your paper.
What the heck is happening here? Uh-oh.
Okay.
I think I must have knocked the camera by mistake. Let me put that down now. Can you see it now?
Yes.
Right. It's a bit crushed, actually, so I'll have to be careful about that. So this fella here, right, needs to get these 2 guys. So I'm going to do a y plus 2 and a y minus 3. Now, this middle term has got a y plus 2. And basically, you give it the bits it doesn't have, right? So it has a y plus 2. Doesn't that mean it needs the other 2 pieces in? Now, the last one has got a y minus 3. And so what's missing is the y plus 2, which I don't have room to write in. So we are now going to be having this fella. And he's going to become a lots of y plus 2, y minus 3, plus b lots of y minus 3, plus c lots of y plus 2, all over the same guy. And now we can ignore the bottom and focus on the fact that the tops have to be the same, the numerators. And pretty much that's the beginning of all partial fraction questions. So isn't our goal now to find out what numbers A, B, and C are? And the strategy that we're going to use in this case, choose a y, not an x, but that's a minor difference. When all the terms are linear, as they are here, we can do a little bit better. And by that I mean we can cut down our workload, so it's not as long as it might be in other situations. So as long as every single one of these is linear, right? Y plus 2, 2y plus 1, whatever. Okay, give me a y value that I could choose that would help us out here.
0.
Wouldn't choose 0 in this case. Choose the y value that makes 2 of them disappear and keeps 1 alive.
3.
Now, if I choose y equals 3, won't that become 0 and disappear? If I choose y equals 3, won't that become 0 and disappear? So that's a good choice. Let's see what we get then. 3 times 3 is 9, 9 fours are 36. Take away 18 is 18, take away 12 is 6. I hope that is 6. This is A times nothing. This is B times nothing. And this guy is C times 3 times 5. And I better check that number again. It may be correct, but let's double check. 4 times 3 squared. Take away 6 times 3. Take away 12. It is 6. Okay. I wish it was a nicer number. Won't that allow us to get C then? Well, I guess it does cancel a little bit. 2/5. Same guy. Choose a different one this time. So think of a number for y that kills off 2 of them and leaves only 1 behind. And now we've already done 3, so we don't use that again, right? We have to pick a new one. What would be a choice this time? And somebody said 0, and I went and knocked it for 6, didn't you? So you, Sam?
Yes.
And I apologise, because it is a good choice. And I said it wasn't. So let's see what you get. 0, take away 0, take away 12. Okay, I can handle that. That's negative 12. A times 0 plus 2, which is 2. 0 take away 3 is negative 3. B times nothing, C times nothing. And we now have negative 12 is negative 6A. And that gets me A is 2. We're almost done then. There's only one guy left, isn't there? And the guy that I don't know the value of is B. Agreed? So I need to pick one more y that leaves this intact, but makes these 2 guys essentially disappear.
Will a y of -2 do it?
Yeah, we would. And -2 is 4. 4 fours are 16. 16 are 12. Take away 12, so 16. And this fella here becomes a times nothing, so that's just nothing. This guy here is b times -2 times -5, and that guy's nothing. That one's nothing. So we have 16 is 10b. So this guy, oops, is b. And we have 8/5. So we now know who A, B, and C are. A is 2. So 2 over y. That was A. B comes next, and B is 8/5. So it's 8/5 over y plus 2. C is 2/5. So 2/5 over y take away 3 dy. And that's what the partial fractions process allows us to do. It allows us to take a single fraction and break it into baby fractions called partial fractions. And the good news is that aren't each one of these easy to integrate. This fella here is 2 log y. The fella next door to him is 8/5, the log of y plus 2. And the last one is 2/5, the log of y minus 3. And I'm going to do a little bit more. Do you know how normally I ignore the absolute values when you do logs? Especially when it's the indefinite ones with the plus c's. But now and again, you have to do it. Can you see that in this question here, if I plug in 2 or 1, I get a rather ugly log? If you plug in 2 here, won't I get the log of -1? And if you plug in 1 here, won't I get the log of -2? So this would be an exception to the rule where I think actually putting in the absolute value will allow you to get a number that works. So in this term, it then becomes a log of 1 and the log of 2, and they're easy to do. So if you are plugging in numbers into logs, you might be aware that sometimes the absolute value kind of has to be there to make it work. Because you can't find the log of -2, it doesn't exist as a real number. But you can find the log of the absolute value of it, which is 2, and that you can use. So that was a little side issue, but useful to know. Are we cool with that one? Next one I want to do is one with a square in it. So I'm zooming around and I want to find a square, and I found one right away. This is version 8. 17 over x take away 1, x squared plus 16 dx. Now we know that's going to split as a partial fraction, right? So let's work on that guy. Is going to be an a over x minus 1. This kind of comes to what you were talking about earlier today, Kathy. What goes above this fella?
bx plus c.
Right, whenever you get a quadratic, you have 2 terms in the top. Now, this fella now has to get joined. A little bit less work, because don't you just have an x squared plus 16 missing on this one, and you have an x minus 1 missing on this one. And to save a line of working, I'm going to skip a line and say the top, which is this guy, are equal. Are you okay with me missing line number 2? We go with that? Top line equals 17. We are in the same world as we always are going to be in. Only this time, because there's at least one term that's not linear, we have to do a little bit extra, and you're going to find that out after we choose the first one. The order this time is much more important. The other time you could have actually changed the order and you still get the same answer. But in this question, there's only one value of x that you should pick.
1.
Correct. Why are you choosing 1?
Because it cancels out B and allows us to find A.
Right. Doesn't it cancel out all of this because this is 0? Agreed? So what have I got? I've got A times nothing plus 16, which is 16. Yeah. Plus 0. And that makes A 17/16, which is, you're just going to have to live with it, right? You're just going to get ugly numbers.
No.
It's x squared.
No.
It's x squared. Oh! I am happy. E is 1. Much nicer answer. Thank you for catching that. Now, this is the difference. In these questions here, once you know what A is, you rewrite this line, but replace the A by 1. And then you can do the choose guy. If you don't do this line, you'll have an A floating about, which will just freak you out and you won't be able to figure out the B or the C. Now, in this question, we have B or C to find. And I can't pick x equals 1 because that's been used and it's done its job. But there's only one value of x that's going to do any good this time.
X equals 0.
Correct? Why?
Because it cancels out the bx.
And that means I only need to have a C, right?
Yep.
Our goal is to only leave one letter behind each time we choose an x. Right. So 0 does the job. So 17, nothing squared plus 16. I get that. Oops, I get that correct. And then nothing times C basically just gets you a C, right? Nothing plus C gets you a C, and a negative 1. And that gets you 1 equals negative C. So that makes C negative 1. I hope I did that one right. And that means we now rewrite this line as x squared plus 16 plus bx, take away 1 because we know C is 1, x minus 1. And now we're left with this guy. And yep, one more choose. We can't choose 0 again. We can't choose 1 again, right? But apart from that, anything's up for grabs. Who should we choose this time?
Two.
Yes, that's a good answer. That's one I'll use. Why? Why 2? Why not 4 or 29? Actually, don't all of them work?
Mm-hmm.
Agreed?
Mm-hmm.
So if all of them work, just pick whatever one you feel like. I like 2. It says, whoops, it's as good a number as any. I don't like 0. That wouldn't help. Could probably have actually chosen 1 if I think about it. So any number, as long as it's not one you've used, would be a safe bet. So 17 equals 2 squared plus 16 plus 2b, because x is 2, take away 1. 2 take away 1 gets me 1. 17 equals 20 plus 2b, take away 1. 17 is 20 plus, why did I do that? It's 19 plus 2b. Negative 2 equals 2b. Negative 1 equals b. We got our b. So we can now go back here, and instead of a over x minus 1, we'll have a 1. And then we have a bx plus c, which ends up being a negative x, negative 1 over x squared plus 16. A little bit messy, but we can do them separate, right? Actually, now I think about it, shouldn't we do all three of them separate? I'm going to break this into two separate pieces. This is technically a plus here. This guy is a natural log. This guy is an inverse tan. What is the integral of 1 over x squared plus 16? What kind of inverse tan is that? We did that yesterday. What kind of inverse tan is 1 over x squared plus 16? Last chance. Anybody?
I'm not. Well, I think you're doing the wrong one.
That guy. It's a quarter.
4. Okay.
And I'm dotting this middle term because it's going to involve some work and we have to move on. What method will I use to integrate x over x squared plus 16?
U sub.
U sub, right? So there's still a good 5 minutes worth of work in that question. Okay, try and remember. If you don't remember it, will you at least write that guy down on a piece of paper where you write all the other things I need to know, and hopefully that will help you remember for the next time. Call that one good? Right, so we've done basic linear ones, right? The y over y minus 1, y minus 2 guys. We've done a quadratic guy. We want to do a square of a different kind. And I know there's one here floating around. If I find it, we'll use it. Here we go. Oh, excuse me. This is a version of question 7. We're going to have x squared plus x plus 1 on the top. And we're going to have x plus 1 squared, x plus 2 on the bottom. Now, we only talked about this once yesterday. But when you have an x plus 1 squared, it breaks into two separate partial fractions, and so does the x plus 2. So there are actually going to be 3 partial fractions here. You're going to get an x plus 1 guy. You're then going to get an x plus 1 squared guy. And then lastly, you're going to get an x plus 2 guy. So whenever you have an x plus 1 squared, it generates 2 separate fractions, right? This one and this one. Now, when we put these together, think of what they're missing. That's how I think about it. this is what I need. It's only got an x plus 1. That means it's missing another x plus 1 and an x plus 2, top and bottom. Now, what about the middle one? Well, it's got the x plus 1 squared, so it's only missing a single x plus 2. And what's the C got? The C's got an x plus 2, but doesn't that make it missing an x plus 1 squared? Are you comfortable about how you can figure out what each piece needs to be able to put together as a single fraction? It's essentially, what is it missing? What's it not got that this has? Now that gives me a top line that looks like that, and followed by that, followed by that. And it's going to be x squared plus x plus 1. And now it's time to choose x's. Who am I going to pick? And be very careful about who you pick.
Shouldn't
Remember,
have an x plus 1 squared next to it?
which one?
The a. Because that's what it was missing. The a, sir.
The A? Okay. It's got an x plus 1, so it's only missing one of them.
Oh, okay.
But yeah, it's worth pointing out in case I did screw up. Okay, what value should we choose for x? I guess we could just guess, but that's not a good
-2.
idea. I like that. Can you explain to the others who were thinking about it why that was a good choice? What does that do that's helpful?
Well, it's the only one that all three of the terms don't have.
So it'll essentially kill these two, won't it? Right. So, oops. If you choose x equals -2, this becomes 0, and this becomes 0. That means they disappear, and you're just left with a c, with a number, of course. Right, -2 squared is 4. Take away 2 is 2. Add 1 is 3. 3. A times nothing gets you nothing. B times nothing gets you nothing. And C times -1, because that's what you get when you do that, and square it is 1. So we have found C. And like we did last time, if there's ever a square involved, you have to rewrite the line with the new piece of information. And now we're ready for choice number, the second choice. Can't pick that, right? Already used up. Give me another guy to pick instead.
-1.
I like it. You want to share why?
Because they would cancel out the a, and then the x plus 1 on the right side, that would also turn to 0.
So you're just left with a nice guy in the middle and everybody's happy. You see that? So let's take that through. -1 squared is 1, take away 1, that ends up being 1 then. A times all of this is 0. You plug in -1 here, you basically get B times 1. And if you plug it over here, you get another 0. And we have now got B. And then rewrite the information as A, x plus 1, x plus 2, a B, which is basically one of these, and 3 of these.
Did I miss your explanation on how we got rid of the x plus 1 on the B? Or Oh, never mind. I was looking at it differently. We're fine.
We're good. Right. You do what I do. I sometimes verbalize my question. I say it out loud. And when I say it out loud, my brain processes it. And then my brain answers my question. It drives my wife crazy sometimes. Because I'll say, why don't we do this? Oh, no, we don't need to do that. That's happened. So it's almost like she's not part of the conversation. So I know where you're coming from. I do that. Okay. Back to the question. I need an X.
Can I just use one?
Okay, that works. Why?
We only have one like variable left besides x, so like yeah.
Yeah, so pretty much any number you like. Could you pick 42?
Yeah, but it's
Yeah, but I wouldn't want to do 42. It's horrible. One's nice. Me personally, do you know what one I like to pick in this last stage, if I'm allowed to? What number do you think I choose in this last situation? One is totally fine and do it.
0.
Yeah. Do you know why I like 0? It's harder to screw up with 0. There's less chance anyway. Not that I can't do it, because I can, but 0, 0, and 0 gets me 1, right? 0 plus 1 is 1, 0 plus 2 is 2, so that's basically 2a. 0 plus 2 gets me 2, and 0 plus 1 is 1, 1 squared is 1, 3 times 1 is 3. And so it looks like what I'm going to get is negative 4 is 2a, and that gets me a. So far, so good. Right. So I'll return to the original. What's happening with this thing? It's weird. Being awkward, I don't know what's wrong with it. Right. It's going to be split as an a over x plus 1, a b over x plus 1 squared, and a c over x plus 2, right? That was what we had. So a is worth negative 2, so I'll do that separate. The b is 1, so I'll do that separate. And the c was 3, so I'll do that separate. Right, so you basically just think of 3 separate integrals. Won't that get you a log? Won't that get you a log? How am I going to get that guy?
U sub?
Correct. Which u sub?
X plus 1.
Yeah, and well, a couple of minutes later, you'll have the answer, right? So we've seen the 3 main situations that you're going to encounter, right? When the partial fractions are nothing but linear terms, right? Like an x plus 1, x plus 2 in the bottom, right? We just looked at that. What do you do if there's a linear like x plus 1 and then an x squared plus 4, right? We've seen that. And what do you do if it's like an x plus 1 and an x minus 3 all squared, right? Which is essentially what this one is like, right? They are all essentially the same process, but don't you have to tweak them a little bit depending on what information you've got and how you go about, especially how you go about choosing your x's? And have you noticed that in the ones that have squares, once you know somebody, don't you rewrite the question with that piece of information? And then you get another guy and then you rewrite it. When it's just linear, right? When it's just x minus 1 and an x minus 2, can't we do away with that line of working because it doesn't really matter? You can get the answer without it. When you do linear, it doesn't actually matter which x you pick first, second, or third, you'll get the right answer. But when it's square, guys, right? Isn't there, you have to pick somebody first, right? There's one choice that needs to be made first before you can do any other choice. So that means that you have to be more selective about not just what value of x you choose, but when you choose to use it. Right? If you do it at the wrong time, it kind of doesn't work.
I do have a quick question.
Yes.
So in this problem, why did you say that we shouldn't choose x equals -1 first?
Oh, from this one up here, why we shouldn't choose x equals -1 first? Actually, you could have.
Okay.
But don't choose x equals 0 first.
Yeah.
Right.
Okay.
So it's maybe not. It does depend on the context. You got to look at the situation in front of you, because I can imagine having a different world where different combinations might say that's not allowed because it ends up having two variables. If your choice of x, whatever it is, means that everybody disappears except one of the letters, A, B, or C, it doesn't matter, then you've got a good choice. Right? So if you pick x equals 4 and two things disappear as zeros and one's left alive, that's a good choice. That will work. Right. But in some combinations, that's not going to be the case. So now we have to move on, and I'm going to talk a little bit about question 9, but only for setting up purposes. Okay, if you were doing question 9, would you agree it's not really written in the form that partial fractions needs to be written in? What can I do about the bottom?
Pull out next.
Okay. Right. Isn't that ready for the partial fraction process now? Now, there's going to be a little hiccup at the end. I don't know what the number is. Can we pretend that it's 5 halves over x squared plus 5, right? Imagine that's one of the pieces you got. You're going to do an inverse tan of this. It gets a bit messy. When that number's 4, 9, and 16, you get nice fractions, right? Can you see where that 1 over square root of 5 thing is coming from and why it's a square root of 5? If that's 9, because you know the book keeps saying the book, you know the software randomly generates numbers to go here and here, and some of you are going to get a nice number like x squared plus 9, and some of you are going to get an x squared plus 17. You get what you get. I think that happened in the test. If you ever had the chance to talk to each other about the test, some of you got questions where the WebAssign gave you actually quite nice numbers that came out reasonably tidy. And then some of you got 17 415ths, right? Some really ugly. It's the randomness of the program. Okay, now, that was just a little side issue. Let's look at substitution. So this is question 10. Whoa. They even tell you make a substitution. So as a U sub question. And every rule in U subs gets broken. You know, we have rules like the ugly guy inside the square root is a good candidate for the U sub. I say it in that way, it's a good candidate, rather than say it's always that guy, because there are always exceptions. For instance, isn't log x over x an exception to the U sub rule? The U sub rule is, if you've got a fraction, the guy in the bottom is a good candidate for the U sub, right? So there are exceptions you've met. This one is the weirdest exception, I think, of all of them that you've seen. Who's the U sub? And I'll tell you, it's not x minus 1, which is what you would expect it to be.
Is it x cubed minus x squared?
Oh, I see what you're doing. Do you know that might work, but I'm not going to do it, Samuel? The one I've got's pretty weird as well. Actually, yours is weirder, but that's fine. Give me a U sub that's not the one you just said.
Is it the square root of x minus 1?
It is. And I don't know how many times I've probably said to you, don't use the whole square root as your U sub. Only use the guy inside the square root. You recollect me saying something like that at least once, right? But here's an exception. You do actually use the entire square root of x minus 1. Now, if I want to differentiate that, I'm going to have to call it x minus 1 to the half, right? And now I'm going to differentiate with respect to x. And that's a power rule. Multiply by the power, reduce it by 1. And now I'm going to spend a few lines that I normally wouldn't do, but in this is a special case. Would you agree it's that guy? Right. And then it's that guy. So far, so good. Now I'll do a little crossover thing. Only this time, which doesn't happen very often, aren't we finished? We've also isolated the dx. So over here, I have 1 over x, the square root of x minus 1, times dx, which becomes 2 lots of the square root of x minus 1 du. And that cancels, which is really nice. Oh, darn it. We have an x left over. None wrong with that. That's what's going to happen. But it is a problem, isn't it? Because you can't have x's. Don't we have to figure out some way of turning that x into an expression with u? Well, I'm going to return back to this guy. Can you think of how this might help you figure out what x is?
Could you solve for x?
Could you what? Damien? Could you?
Solve for x.
Okay, sounds like a plan.
Is
So
it
how
u
about,
squared plus 1?
well, let's square both sides, solve for x, and add 1. Oh, that means x is u squared plus 1. Now, don't overthink this one. I don't even need partial fractions, so I'm not quite sure why this question is where it is. But it might be the randomness of Weber sign. Do you know the answer to that integral with respect to u?
Is it 2 times tangent inverse of u over 1?
Which is just u.
Or 1? Oh.
Yeah.
Yeah.
And then can't we just turn the u into c?
I do have a quick question.
Mm-hmm.
When taking the derivative of your u sub, I may be remembering this wrong, but aren't we supposed to take or multiply what we got here by the derivative of the inside?
Yeah, and the derivative of the inside is 1.
Oh.
So it doesn't change anything. But you're right. That would be more important if it was 2x minus 1, because then you'd have an extra times 2. So technically, that's to be done. But if the number is 1, I just didn't mention it.
Okay.
I don't know if we've done this, but just in case we haven't, will you say hi for attendance? And tomorrow we're going to have to do some more of these guys, which means I'm going to spend less time on the table stuff, but that's fine. Table stuff's not a major thing anyway. It's just a shortcut to finding integrals. Okay. If that is us, I am out of here. If any of you have a